So for 7.6, linear programming takes those systems of inequalities, that shaded region from it, and then applies another equation to it, the values, to try to either what they call an optimization equation, where you try to maximize your values or minimize. Okay, so linear programming, the idea is you're going to do this optimization. You're going to look at your constraints, and you're going to have an objective function. So the constraints part's just the same stuff as what we did yesterday. Okay, with graphing the inequalities, doing the shaded region. Objective function will be another function for it. So if you have this feasible region, this shaded region, and you want to maximize or minimize actually the value of this function, well, what you're going to do is actually plug in these x and y values. Now, it could use anything in this region whatsoever. The thing is, you have an infinite number of points. So any of them would work, but not for the perfect either highest or lowest value. For the highest and lowest values, those are always going to occur at your vertices. So what you want to do is find those vertices and then plug them into whatever the optimization is. And that's honestly what the section comes down to. Okay, they just talk about steps for this. You sketch the region, that's the same stuff. Find your vertices, then test the objective function, that optimization function. So, start off with an easy one. I want to find the maximum value for this function. So that's my optimization. My constraints are these three equations. So what would I do to start? Graph your constraints. What's the x greater than or equal to 0, y greater than or equal to 0 going to tell me? Quadrant 1. So you're shading inside of that quadrant. And then how do I graph this one? Yep. You have y-intercept and x-intercept are both 6. Solid or dashed? Solid. Now, because you're doing these optimization ones and you're going to use vertices, well, if it's dashed, do you have vertices? No. So they're all going to be solid lines. Am I going to shade towards the origin or away from it? Towards the origin. So you just end up with this triangle. So then what would my vertices be? 6, 0, 0, 6. Any others? 0, 0. So you have those three vertices. So the only new piece of information is I'm going to take those three vertices and plug them into this z function. So when I do that, I'm going to take 4 times that 6 plus 5 times 0 gives me what? 24. 0 times 0, 6. When I plug that in, I'm going to get what? Say again? 30. And if I plug in 0, 0, 0. So, which one's the right answer? 0, 6. So what I would say, because it wants me to maximum value here, so it's going to be that 30. So the way I would answer this, you would say has a max of 30 at that coordinate 0, 6. That's actually how you would write out your answer. Not too bad? Sometimes the equations can be a little bit more complex. How many constraints do I have here? Careful. How many constraints? 6. Because this alone is how many? 2. This means you're shading what part? Just based on this alone. Between the 0 and the 60. So the idea, the greater than 0 here is still going to limit you to the first quadrant. You're going to go 60 on the x, 45 on the y, but I need to figure out where my other values are. So I'm going to take these, and I'm going to look at the x-intercept and the y-intercept for it. So what would your x-intercept be for that first one? Say again? 84. What would your y-intercept be? 70. X-intercept for the second one? 10. Y-intercept, 20. So, where would I want to go to on the x-axis? Okay, you look at your biggest value for the x. 84. So I want to go at least past that, right? So if I do something like 90 here, 45, and then split these up by 15. So something along those lines. Or you could do it all the way to 100 and just do steps of 10, whatever works. You just don't want to go too short when you have to go all the way out to 84. On the vertical, what's your largest value? 70. So if I just do 70 for that, just go up by 10s, about right there. Okay. Let's see, then graph them. 0 and 60. 0, you already have the y-axis. X equals 60 would be right here. And you're going to shade between them eventually. What would I graph for this one? Go up to 45, then straight to horizontal. Shading? Down from that one. So you're somewhere inside of this rectangle. Here, 84 and the 70 connect them. So let's see, 75, call that 80, 84 then would be about there. And the 70. Honestly, it doesn't hurt to have a straight edge for some of these. Take a note card or a piece of paper or something, just to be able to draw it fairly easily. If it wants to slide for me, there we go. Am I going to shade towards the origin or away from it? Towards. Plug in 2 zeros here. 0 is less than 420. For this one, let's see, 10 on the x, that's 15, so 10's about there. 20 on the y. Am I going to shade towards the origin or away from the origin? Away. So your shaded region is this, what is that? 1, 2, 3, 4, 5. Hexagon. So that my vertices are whatever corners are touching it. So what are the easy vertices? 0, 10. Oh, 10, 0. What else? 0, 20. What else? 0, 45. 60, 0. That's the easy ones. For the other ones, what do I need to do? Find the intersections. Now the nice thing is, what's the y value or the x value right here? 60. So all I need to do is take 60 and plug it into which equation? The third one, the 5x. Plug in 60 for times 5 is 300. 300 away from 420 leaves you with 120. So y is what? $120 over the 6, yeah, is what? It's 120 divided by 6. 20. So it's a 60, 20. If he can barely hear you in front of you, then when he's sitting in front of you, I really can't hear you from here. For the other one then, what would I do? What value there do I know? 45. Which equation am I going to plug the 45 into? Third one again, yep. Plug it in here. 6 times 45 is what? 90 times 3. 270. 420 minus 270 is what? 150. 30, yep, divided by 5, you get 30. which if you look visually, that's about right, 30. It's right above 30. Okay, so then what do I do with all those?
Plug them into the one equation.
Plug it into that z equation, that optimization equation at the top. So, 10, if I plug that in, gives me what? 120. Plug in 0.20, I get 160. Plug in 45. 45 times 2 is 990 times 4 is 360. Plug in 60. 6 times 12 is? 720, 72, yep. Plug in both 60 and 20. Well, that's going to give me the 720 plus 160, which is what? Say again? 880. Plug in 30 times 12, 45 times 8 gives me 720. So, what's my solution?
10, 0.
Yeah. Minimum value. Make sure you look for what it's asking for. So the lowest value you have up here is 10, 0. So what would I actually write for a solution then?
Min of 120 at 10, 0.
Min of 120 at 10, 0. Not too bad? Remember what I said, though. They don't always hand you the constraints or the equations.
Oh.
When they hand them to you, they're not too bad. These, you got to do a little more work. Where do I want to start? I don't want to start with the equations.
Well, reading the thing.
Oh, reading the problem. Okay, I thought you said equation.
I did.
Okay, so pet store mixes 2 brands of dog food. Brand X costs $5 per bag. Contains 2 units of nutritional element A, 2 of B, 2 of C. Brand Y is $4 per bag. Contains 1 of A, 9 of B, and 3 of C. The minimum requirements for A, B, and C are 12, 36, and 24. Find the number of bags of each brand that should be mixed to produce a mixture having a minimum cost. So where do I start? Well, where did we start yesterday?
With the constraints.
We didn't start with the constraints.
Writing out everything we need.
Not quite. Say again? Well, we define the variables, yes. So if we have x and y, we're going to assume it's linear since it's linear programming. Is it of brand of what now? What about the brand of dog food?
Number of
Bags. Look for the question in the problem. Look for what they're asking you to do. Find the number of bags of each brand. That's your variables. So x is the number of bags. Y then would be number of bags of brand Y. Once I have those, then you got 2 options. Either I can do my constraints or I can write my optimization equation right now. I sometimes like to do the optimization equation just so it's out of the way and you know you don't need to deal with those numbers anymore. Okay? For the optimization, that's going to be Z, typically, just to have it off to the side. Now it's going to have to do something with this X and this Y. What am I trying to optimize? Minimum cost. Look for the word minimum or the word maximum. That's your optimization. So I'm trying to minimize cost. So what's the cost of X? $5 per bag, and X means number of bags. So plus 4Y. So I've now used those 2 things. I don't need them for the constraints, that means. Okay? So if I ignore those now, what are my constraints going to be based off of?
The amount of nutrients.
It's going to be
Well, yeah, those will be two of my constraints.
I just think those would be easy to get out of the way.
Yeah, I usually leave them till last, but because they are so easy. But you can do them first, whatever.
Okay, I'm sorry.
What are your limiting factor? What are your constraints in the problem? Yeah, your different types of nutrients. Your element A, B, and C. So that's what I would write out here. Your A, B, and C. Now the idea for this is I'm going to have whatever your variables are, those combined are going to be equal to your limitations.
Don't we also need that X is greater than 0, Y is
Yeah, that's what Austin was talking about. You all will also need X is greater than or equal to 0, Y is greater than or equal to 0, because you can't make a negative number of bags of dog food. Yeah.
I think it should be 1 because it says it mixes 2, so it can't be 0 either.
No, potentially it could be though. You could the optimum could be just having the one brand and ignoring the other one entirely.
I'm thinking that because it says it mixes the 2.
Yeah. But a mixture could contain 0 of one thing and all of another. It doesn't really make English sense, but mathematically it does. So then, what are the constraints going to be for A? Or actually, let's look at it this way. Some people like writing them this way a little better. Brand X, fill in all the information for brand X. So that's everything from here to here. So 2 for A, 2 for B, 2 for C. Oops. Make sure you put the X there. Now each one of those you're going to add the limitations on Y, which is what? So 1Y for A, and 3 for C. Now, A, B, and C respectively have a limitation of 12, 36, and 24. Now, is that going to be greater than or less than? Why?
Because it's a minimum requirement.
Right, because here it says the minimum requirement means this has to be greater than or equal to, greater than or equal to, and greater than or equal to. Okay. So then, what's next? Graph it. Now to graph it, I know I'm going to need I know it's in the first quadrant, as honestly pretty much every one of these will be. I also have that I need to find your x and y intercepts here. What's your x-intercept for this one? 6. Y-intercept? X-intercept? Y-intercept? 4. X-intercept? Y? 8. So what would be a logical, how far to go out on the x-axis?
20.
Could do 20, but I'm honestly looking at this, I'm seeing 6, 18, and 12.
Ooh, 18.
I would probably actually do 18 and then just split it into what? Thirds? So 6, 12, and 18.
Most logically,
What about for the y?
12.
Yeah, I would use 12 and again just split it into thirds. So then the first one here, draw your lines. 6 on the x to 12 on the y. 18 and 4. 12 and 8. What about shading? Everything away from the origin. So you're going to be outside of all of those lines.
It's like a weird.
So then where are my vertices at? Well, that doesn't actually affect anything as far as which are the vertices. You still have the same vertices.
18,
0.
0, B1 though?
Potentially.
Outside.
Yeah. All these ones where the shaded region's touching. So you have those two. You also have these. So another thing, you might want to label which line's which. The one that goes from 6 to 12, that's A. The one that goes from 18 to 4, that's B. And the one that goes from 8 to 12, that's your C. Okay? The easy one, what are your vertices?
0, 12, and 18, 0.
Okay? Then, to find the others, what do I have to do?
Plug in.
Plug what in? Well, I have other vertices though, right? What do you mean by plug what in?
No,
Just disregard
value.
So I want to find this point here, right?
Yeah.
This point is the intersection of what two lines? C and A,
So when you're
right? So what would I do to figure out where C and A intersect? Solve the system. Take both of these equations, A and C, copy them down. So if I take, I'm just literally copying these down up here, so I'll go up there in a second. So I have the 2x plus y is equal to 12, and 2x plus 3y is equal to 24. So this is your A and C equations. What do I do with them? Subtract. Use elimination. X's go away. What do you have in front of the y? In front of the, or for the constant? So y is 6. Plug that back in up here. 2x plus 6 equals 12.
3.
So x is 3. So that's your next one. 3, 6. Then what?
Same thing for the other two equations.
Which other two equations? B and C. Okay. So B and C equations, go ahead and find that. What do you get for y? 2. If I look at these two equations, subtract them, I get 6y is equal to 12, so y is equal to 2. Plug that back into one of them. So you have 2x is equal to 18, so x is equal to 9. So take your 9 and your 2. And then what do I need to do with these? Plug them into the equation right here. So that's going to give me 4 times 12, which is 48. It's going to give me 5 times 18. 90. 3 times 5 is 15. Plus 24 is 39. And 45 plus 8 is 53.
So 39.
So what's my answer?
Minimum $39
Minimum of $39. Now, you need to be a little bit more verbose when you're doing word problems. For a mixture of how many bags of A or X? 3 bags of brand X. So that would be your answer. Questions? Okay. That's everything for this semester. Those ones take a little bit of time. I would not expect to see more than one like that on the quiz or the final, but I would expect to see one. Get to work.